afternoon, or good morning. This is Jose Fuentes, and I will be your host during today's webinar. The topic of today's webinar is a lovely one. It's kind of a fight between script languages like DOORS DXL and natural language processing. So let me start by introducing the presenter of today's webinar, Dr. Simon Wright. Simon has a Bachelor of Science and a PhD from the University of London. For over 15 years, he worked for GEC Marconi on various defense projects. He then moved into the commercial software world, initially with the system modeling tool Cosmos, and then with the requirements management tool RTM. For the last 13 years, he helped many organizations with their requirements engineering, including the Russian Atomic Energy Authority in Moscow, the European Space Source in Lund, Novo Nordisk in Denmark, and the Norwegian Army in Oslo. He's an experienced lecturer and has trained many hundreds of people in requirements engineering in a variety of countries. Simon is a good public speaker and has presented at over 30 conferences and seminars in the UK, in the US, and in Europe. So the content of today's webinar is as follows. I will start with a brief description of the various company. Then Simon will take over with a deeper background and he will speak about requirements quality in general, brief history of this. And he will be comparing the methods and functions needed to undertake textual analysis and natural language processing, and some semantic checking, correctness, completeness, and consistency. Then the question comes, can script-based languages such as DOORS DXL hack natural language processing? And then finally, we will conclude with some questions and answers. So about the company, probably some of you already know our company, TRC, the Reuse Company, is a good acronym not only for this TRC, but also for the main three pillars of our technology. If I can make a little change between this C and the Q, because Spanish quality is spelled with the C. So now with the Q, we are more comfortable in English for our three main pillars: traceability, retrieval and reuse, and quality. These are the three main activities that we perform in order to improve the project performance in our customers, and all this is based on a knowledge-centric approach with ontologies and artificial intelligence and natural language programming as a key enabler for this improvement. These are the four main tools in our tool suite. Probably some of you who already know us for a long time, probably you think of three tools in our tool suite. Now in this version 18, we have included the fourth tool. So we can say that we have SQA, the quality analyzer, just to set up what should be the rules to be checked against our requirements or our models. Because in this version 18, we have extended the number of artifacts we can analyze in terms of quality checking. Then we have the authoring tool, allowing us to have real-time quality checking and to write textual sources such as requirements or risks based on textual patterns. All this is enabled by ontologies and some knowledge stored in our repositories. And all this knowledge is managed by System Knowledge Manager. And then finally, the last tool who has joined this TRC suite is SIM, System Interoperability Manager, that allows us to perform some activities such as generation of models out of requirements, or traceability, or even reasoning. This is a brand new tool, and we will announce different webinars of this brand new tool. About our company, again, our headquarters is here in Madrid. We have main offices also in London and Stockholm. The one in London is headed by Mr. Simon Wright, the presenter of today's webinar. And we have offices mainly in Europe, the US, Japan, and Australia. Our main customers are coming from the aerospace and defense industries, automotive, energy, consulting. These are mainly our safety that's all from my side. I now hand over Mr. Simon Wright to proceed with the webinar. So Simon, is you ready? Now let me try to assign presenter Wright for you and unmute you. Simon, you are now on mute.
Yeah, can you hear me?
Yeah, I can hear you.
So, just a little bit more about me. I just wanted to point out that for 10 years I earned a living as a rational DOORS consultant and DXL programmer. I'm still open to offers. I can do that from time, I'll still do that. Here are some of the projects that I worked on, which were big, heavy DOORS users, big, heavy users of DXL programming. I respect DOORS a great deal. It's a mature tool for managing requirements. I should point out I have my own license, not a company license. This is one I have bought with my own money. This year's maintenance and support cost me £1,000, well, that's 1,200 euros. And I just want to point that I am committed to the tool, but I'm not biased for or against DXL at all. I have the utmost respect for the tool. I'm not here to denigrate it in any way. It's a good requirements management tool, but our subject is requirements development rather than requirements management. And I want to have a brief review of the history of requirements development, or the development of requirements development, particularly requirements quality. So the first person an interest that got me started on all this was sparked by this lady, Ivy Hooks. I met her in the mid-1990s, a lovely lady. The title of her paper, which she gave at the INCOSE conference, refers to good requirements. It took another 3 years before the next paper that I came up with. And again, that was talking about good requirements. The next paper that influenced me a great deal was this one, Writing Effective Natural Language Requirement Specifications. This was instrumental and opened my eyes to different ways of looking at improving the quality. But I should acknowledge also Carl Wiegers. I met him in 1998. We had an animated discussion for a long time about requirements quality. I am very grateful to him. He recommended me to replace him as the requirements advisor on the IEEE software magazine. So my thanks to Carl. So these are the earliest papers that I found concerning requirements quality, initially about good requirements, but eventually the term quality crept in. Actually, they're still worth a read. So you can go back to them. I'm sure you'll get these slides later on. So what about tools? Well, about the earliest tool that I came across was the ARM tool from NASA. It was available as a prototype in 1997, and this did ASCII text analysis. The next tool, forgive my lack of humility here, but I was very much involved with another tool called the Requirements Counselor. This came out of an EU IT project called Precepts. We made it available in 1999. This was a Word document plugin. It was still doing textual analysis, but not of ASCII text, but actually of Word documents. And I presented this tool, and it was made available here in 1999 at the RTM Users Workshop. I still have a copy of that presentation. If anybody's actually interested in it, I can make it available. The third tool that was around about this time, which I acknowledge gratefully, is the boilerplates by Jeremy Dick. This was a DOORS plugin, and this was very much looking at linguistic patterns. I couldn't find an earlier reference than the one I've given there to it. I do apologize if there is an earlier one to Jeremy, but this is the one that I found. So these tools were coming out not long after the papers on requirements quality were published. So what about DOORS and tools for DOORS? Well, I know of two. One is the ARM.DXL by Ian Alexander. It's dated 2006, and he says it's loosely based on NASA's ARM. A lot of them are, and it's a text analysis tool. The other one that is worth mentioning is the one by Tony Goodman, and his dated 2008. He extended that work done by NASA and did some more textual analysis and can give quite a comprehensive set of results out of the from your DOORS database. So this is a very short and brief history. It only has the highlights. In fact, they're only my highlights. These are the papers and tools that have influenced me and my work. So let's have a look now in more detail and address the actual title of the presentation, which is about natural language processing. So I'm going to look at methods and functions to do textual analysis and for natural language processing. Now I'm going to look at syntax checking of NLP first, and we'll look at just the methods that we need for that. After that, I'll look at the methods for textual analysis, and then we'll look at actually the detailed language functions that are needed. So, bearing in mind that this is just the syntax. So, first of all, what we do with our document, our set of our textual requirements, is we tokenize them. Now, what this means is we chop them up into pieces, typically into words, individual words. There is an issue here. How do you tokenize words like can't with an apostrophe? Is it can an apostrophe T is another one, or do we ignore the apostrophe T? Well, then that's the opposite. What about abbreviations like LED? So if we're just looking for delimiters like full stops, this would come out as three different words, whereas in fact it's one abbreviation. So there's some tricky things that can trip you up when you try and tokenize a requirement down into the individual words, or tokens as we call them. Once it has been tokenized, you can then do stemming. Now, stemming is reducing words to their stem or their base root. So the words cat, catty, cat-like all stem from the word cat. And most of the time, particularly in English, it's the little bit at the end. The plural is at the end. The cat-like, the like is at the end. You can actually quite often stem words, many words relatively easy in English. I don't know about other languages. But there's some also things that will trip you up, like what is the stem of better? This isn't a competition. I'll tell you what it is. It's good. The word good is the stem of better. And in fact, there's another technique called lemmatization, and that gets over some of these problems with stemming, which is to do with cutting off the endings of the prefix or the postfixes, and actually getting to the absolute linguistic root rather than the textual root. Closely coming up straight away after stemming is parts of speech tagging, and these two functions, these two methods rather, are what we call normalization. So the parts of speech tagging tells you what each of the individual tokens is. Is it a noun? Is it an adjective? Is it a verb? But of course, particularly in English, some verbs are nouned and some nouns are verbed. In other words, some words act as nouns and verbs. And so what you have to do next is disambiguation. So there'll be a set of candidate tags that we can put on parts of speech tag that we can put on the individual tokens, but we only want one. We want the one that is being used at that particular time. So this is the first three methods that we use. And if we were to input, say, the flight system shall have 3 engines, at the end of tokenization, normalization, and disambiguation, we would have the as the determiner, a flight as a noun. System could be a noun or a proper noun. Well, actually, it's a proper noun at this particular moment. Shall is a verb, but it's also a modal verb. And so we would disambiguate shall to be a modal verb. Have is a verb. And then 3 is a number. Engine is a noun. So we've got a beginning of our natural language processing. there's three more things that we need to look at. So after we've done tokenization, normalization, and disambiguation, we do phrase identification, because often, particularly in requirements, we combined words into phrases. So in our example, flight system actually is a single term. It's the flight system. And so we need to identify noun phrases and verbal phrases and treat them as one individual token. Then we've got to convert any words that are numbers into actual numbers and not words, because we process numbers in a different way we process words for obvious reasons. And then finally, we have the matching process. So having got down to the individual, normalized, disambiguated, phrase-identified tokens, we then say, right, well, we need to group these together in the various recognized patterns, the subject of the sentence, the object, any verbal phrases, is there a predicate, before we then match them up to our knowledge base, our ontology of known words. So what do we get? We started off with this input after the disambiguation, and the output looks something like this. So we know what the subject is, which is the flight system. Flight system is a proper noun made up of flight and system. We know that the verb shall is a modal verb, and we have a predicate, 3 engines. So this is how these are the methods that we need for natural language processing, just looking at syntax. So we can now move to our next part. We're looking just at the methods for textual analysis. So it begins in the same way, which is tokenization, chopping the sentence up into pieces. We've looked at that already. But once we've done that, we don't do any normalization or disambiguation, no phrase identification or changing words into numbers. We go straight to matching. And we need to match what we found against what is stored. Therefore, if we take our same input, the flight system shall have 3 engines, the only output we're going to get is the individual words. So what are the problems with this method or this approach? Well, I suppose I should think of the pros. The pros is that this can be fast, but the problems are that words like catty, cat, cat-like, they're all the same, so therefore they would be treated as 3 separate words rather than one stem. The problem with the book from the book library, again, we got the book used 3 times. Which one is the correct one? And we would we check this 3 times or once? And if we only did it once, which one? We wouldn't detect flight system as a single phrase. Yes, we can detect 3 as a word, 3, but what about 43? 43 is 2 words, but it's only 1 number. The result of all this is that we end up having more words to match than we would have had we done the full natural language processing. So if we're trying to match, say, 1,000 words in requirements, so it's a reasonably sized requirement specification, what we would do is we would then compare that with our words in our database, our ontology, and say there's 100 words in there. That's 100,000 compares. So textual analysis can be performed within DXL, but there is this particular problem, the problem that we've got a lot of redundant checking. Although a reduced set of methods could have increased processing, due to duplication of terms, we could actually then increase the processing yet again. So it's a swings and roundabouts approach. So we've looked at the methods that we need. What about the individual language functions? And I'll look at textual analysis first. So functions for textual analysis. Well, really, they're string functions because we're going to chop up a string. And we don't just need the functions on the string. We've got to store the string in some data structures. And so we need to look at what are the functions that are needed in the data structures as well. So we need to declare a string. Now, a string is an array of characters. I think that's fairly universal across most of the languages that I've come across, that a string is actually a derived form of the primary data structure characters. So a string is an array. When we're tokenizing, what we've got to do is a find function. The words are going to have a delimiter, typically a space or a full stop or a parenthesis. And we need to find the position of the delimiter char in the string. We then need to find the next position of the next delimiter, and then from that we can extract those sequence of chars between the two delimiters as the word, as the token. Now, regular expressions can be, which are supported in DXL, are very useful in this area, absolutely. But it's still quite difficult to construct a regular expression when you've got potential delimiters of spaces, full stop, parenthesis, brackets, curly brackets, whatever, semicolons, colons. So that's the tokenize function. What about the next one, which is the matching function? Well, obviously, if you're going to match two strings together, it's a Boolean comparison. You may just, there are other functions like contain functions. So is this string contained within that string? And also irregular expressions can be used for matching as well, for obvious reasons. It is a match itself, a regular expression. So these are the basic string functions that we need to do textual analysis. But we also have to put this data into data structures. So let's have a look at the data structures. So it's not just a matter of declaring a string. We've got a whole set of strings, and so therefore you might have an array of strings, which is an array of characters. You may put it into a linked list. In DXL, they have skip lists and buffers. So we have to declare these data structures to contain the data, the text that is been normalized and disambiguated. So, tokenize. So what we need to do is we need to add a string to an array, or to the list, or to the buffer. So that's a function that we need, as well as adding data into our data structure, strings into our string structure. We need to be able to remove them from the array and from the buffer. And then we need to do searching, because we don't necessarily want to put the same word in more than once. We want to try, if we can, to avoid duplication for the reasons I gave earlier. So during the tokenization, we've got to manipulate the string data structures. Matching, well, we need to be able to sort our data structure, because if we sort it, it's going to be much quicker for searching rather than having to search all the way through. We can look for the first, second, third letters. Once we've sorted it, then we still have to do the searching to find a match. So these are the basic textual analysis functions that we need. We need to declare the strings, operate on the strings, and store the strings that we have. I hope that's clear. DXL provides all these functions, as well as other languages, things like Python or Visual Basic and things like that. They provide these typical textual, these string functions. It's rather a simple view, I must admit, which highlights the difference between scripts and that's a slide. I'm talking about a slide I've deleted. So let's look at some issues. String memory management. If we're going to implement in DXL, we have to think about memory management. Tony Goodman points out there is no function for deallocating memory used by string variables. Every new string declared or constructed in DXL is added to the string table, and that uses up memory. And it's not released by DOORS until the session is terminated. Now, for most of the times that we use DOORS, this isn't a problem. But if you have maybe 2,000 or 3,000 words and you're starting to analyze them, say you have 500 requirements, that's probably 5,000 words, and therefore it starts getting quite memory hungry. Now, you can know if there's a problem if you have something that looks like this. Now, admittedly, this was an old computer with limited memory and a slow processor by modern standards, but I wanted a picture to illustrate the problem. So you can see that as more and more strings are used, more and more memory is used, more and more CPU power is used. But there are ways, well-known ways, to mitigate this, and that is to use, to avoid things like static strings and use dynamic variable types like skiplets, arrays, buffers. They have functions that explicitly deallocate memory once they've been used. And we're going to look at what those functions are. If you're really interested in the string table in DOORS, there's a web link. That's an excellent dissertation which explains how DOORS deals with the string table, the ever-increasing string table. So let's have a look, though, at how we can mitigate the string table. And we're going to look at memory management again. Tony Goodman again points out memory deallocation is not automatic, though, for these dynamic types. So that if we use them repeatedly, they will consume memory and they will reduce the performance of DOORS, and in some cases it could lead to DOORS crashing. This can be mitigated, though. To avoid memory leaks, you've got to firstly explicitly deallocate the memory that is used by the variables. So make sure that you've got a delete or destroy function call for every create function in your program. As a DXL programmer myself, I know I forget them, and I have to go back and do a search for them and put them back in from time to time. It happens. But there is another way to mitigate this, and that is to pass data by reference rather than value. You see, when you call a subroutine and you pass it by value, you send over a copy of the whole data structure, which sits in memory, and it's a copy of something you've already got. But if you send a reference to the data structure rather than the data structure itself, then you can operate directly on that reference to data structure. So, referencing is supported by DXL, and it allows a convenient way of limiting data replication, as I say, by passing the reference to the function rather than the reference to the data rather than the data itself. So you can totally get rid of this growing memory leak. The cest buffer or skip list is truly handled in the same as the original buffer or skip list, so that your memory area will be emptied when you issue the delete command. So how do we mitigate this? Well, basically this takes quite a long time. If it haven't been used in the first place, you will spend many hours, and therefore thousands of euros or dollars or pounds or tens of thousands of Swedish crowns or Norwegian crowns, etc., if you're going to go and reprogram your DXL to use the references to the buffers and the skip lists. So, is that the only problem? No. There's one final problem that we need to consider, particularly for DOORS, and that is hidden formatting. So, if you type in the word hello as just your requirement, but it's a rich text string, then what is actually in the attribute? That is what's actually in. That is what the exposed rich text looks like for the word hello. So when you come to say, well, I want to compare hello in my requirements with the standard use of the word hello in my database, you may get a false result because they don't absolutely match, because one is ASCII and one is rich text. And you can't do rich text against rich text, because what happens if the character set is different? Or the way you formatted, maybe it's in bold, I don't know. So this is a problem. So how do you mitigate this particular problem? Well, it's simple. You convert the rich text to ASCII for a proper comparison. And I'm fully aware that there's lots of functions for converting rich text to plain text in DOORS. But this will add to your string table. We've gone all through this exercise to not have additions to that string table, but if we're using rich text, as most of the requirement documents have them embedded in, lo and behold, we're back to the same problem. So we've got some issues here. So the cycle starts again, memory is consumed, leaks occur. So those are the functions for textual analysis. how do the functions of natural language processing check out? And again, this is syntax checking. Now, here are some language functions, but of course, we're going to have some language data structures as well. So what about the functions? Well, we're going to use, obviously, the string functions that already exist, plus a whole bunch of other functions for extracting the entities, as they're called here, which is the same as the tokens, keyword extraction, taxonomy classification, language detection. Now, these functions I've taken from a commercially available natural language programming API service. So this is a representative set of functions. These are not the functions that we have within the tool suites. We have something very similar to these, but this is just to give you a feeling for all the additional functions that you need in order to do natural language processing. But we also need to have, of course, some way of storing this data. We're going to use all the string data structures and functions as well. So we're going to add stuff, take stuff away, sort stuff. But we're going to need relational database tables to do proper analysis. And we're going to need index tables and hash tables to do this effectively. We're going to have to deal with XML, XMI type of data, and that has associated metadata. And then we need to worry about serialization if we're going to transmit not just the data, but the structures as well to other programs. So it's a lot more complicated, the data structures that you need, or the language structures, I suppose, that we need. And unfortunately, DXL does not give you any of these. DOORS is not a relational database. So that these data structures that are needed are in a way, the Achilles heel of DOORS old gen. I'm not talking about new generation, I'm talking about old generation. And this is a real Achilles heel, and let me explain why. And it's to do with semantic checking. So let's have a look at a simple semantic problem. I'm just going to look at 3 words: book, library, and a. And they can be ordered in 6 different ways, but only 3 of them are syntactically correct. And those 3 are a library book, a book library, and book a library. And the problem here is that the word book in the first is an object. Here in the second, it's a descriptor. And in the third, it's an action. So the word book is being used in 3 very different ways. So for example, and this is very simple, say you want to book the book from the book library. You could then analyze this for correctness, syntactic correctness. Now, as I've said before, the library book, a book library, and book a library are all syntactically correct, but semantically they are inconsistent. And I want book to simply be a noun, an object. I don't want it to be a descriptor or an action. For completeness, the next 3 are the ones that make no syntactic sense, and one of them also makes no semantic sense. The phrase book a book from the book library, this is the key. It is syntactically correct, but it is semantically inconsistent. What we should have written is reserve the book from the publications library. This gets even more complicated in a reasonably well-phrased requirement. The temperature sensor shall measure the coolant temperature at a minimum rate of 10 measurements per second. We can analyze this and see the semantics within it, so that you will see that this phrase here, that the temperature sensor senses a temperature. So if we were to write the temperature sensor shall measure the coolant pressure, we would know from this semantic pattern that that didn't make sense. And similarly, over here, we have another pattern, a semantic pattern, a meaning pattern, that if you're doing a minimum value, you've got to have some units, a temperature, some units, and a rate. So these are relationships. We're looking at the relationships between words, and that is why the relationships between these terms are best handled by using a relational database. This helps with getting good syntax and consistent semantics. These linguistic patterns are very, very useful, and they've been known for quite a long time. So these models, this is where I want to talk briefly about this paper by William Wilson. As I said, it was in 1999, and this was a real eye-opener for me, and I've just cut out a couple of his sentences. He talks about specification statements having 4 basic structural elements: entities, actions, events, and conditions. But they can be modified or given more detail. He then comes up with a model for specification statements, which is a little difficult to read. But here's the example. When 3 or more star trackers lose reference stars, the spacecraft shall immediately align its main axis on the Earth-Sun line unless the optical instrument's cover is not closed. And that, when I read this paper, it really did open my eyes to how you really do write a requirement. Of course, this is in 1999. This is about the same time that Jeremy Dick's boilerplates was being used in various projects. And later on, something similar was done with the EARS approach. This is 2009. And they came up with 6 or 7 basic patterns. 6 basic, 1 complex. But again, using the same idea of linguistic patterns. And this is a very powerful technique. It's also been incorporated into a standard, the ISO 29148, Systems and Software Engineering Lifecycle Process Requirements Engineering. This is what they quote for the types of patterns to be used for having a clear requirement. And this is all about the relationship between the various parts of speech that are being used. So, if we do natural language processing, what are the key benefits? Well, there's 2 I'd like to talk about. The first one is mining. Because if you develop these patterns, you can actually use your old specifications to mine for compound nouns. Each domain has its own set of nouns, and they tend to be compound nouns, 2 or 3 word nouns, and also verbs or verbal phrases like conditions. When this happens, that happens, for example. And you can use these patterns to search old documents, and they're really a rich place to find really good knowledge. And what we do with that, you can build your own domain-specific relational database, or as we call it, knowledge base, and that knowledge base becomes a capital asset of intellectual property. It's your intellectual property, and it can give you a competitive advantage for the future if it contains all your domain-specific terms and your agreed linguistic patterns. And the key about this is that if you match terms and patterns together, you can end up with some rules. And this is what was done by Nkosi. Nkosi came up with a guide for writing requirements. And if you read their rules, they read that it's looking for terms like the indefinite article a, it's looking for that, and saying, no, you should use the active voice rather than the passive voice, quantifying precisely the numbers, not saying approximately, almost, nearly, about. So these terms plus linguistic patterns can equal rules. So I'm going to give you what I have dubbed the universal guide to writing requirements. Avoid the bad, enforce the good. But what's bad and what is good? Well, if we look at just 3 examples from the Nkosi rules. Rule number 1 is indefinite articles. What you must avoid is a and an. So the system shall provide a time display. They say, enforce the definite article, the system shall display the current time. Let's look at rule number 5, the imprecise quantifiers. So don't have some, any, several, significant, sufficient, adequate, all those sort of things. Here's a bad example. Displaying altitude to approximately 1 meter resolution enforce quantification of performance criteria. So the flight information system shall display current altitude plus or minus 1 meter. So that's a third rule is pronouns. This is I find this one quite interesting. The guide says you need to avoid it, this, that, he, she, etc. So the controller shall send the driver his itinerary for the day. It shall be delivered at least 8 hours prior to his shift. You need to enforce the role of the stakeholder, the operator or the maintainer or the supporter of the system. The controller shall send the driver itinerary for the day to the driver at least 8 hours prior to the driver's shift. And I hope by now you're spotting in each of these sentences the terms, the words that are being used. So, can I afford to do all this processing even though there are clear benefits? Well, for about $3,995 you can get software to do a comprehensive quality analysis. And yes, I'm talking about the reuse suite. We do textual analysis, syntax, semantic analysis. We apply correctness, completeness, and consistency rules. That's how much it's going to cost you to get started. But what happens if I wanted to use that money in a different way? Well, for €3,995, you can buy yourself a DOORS engineer. This is the current going rate for DOORS engineers in the UK. It's about £400, about €450 a day. So maybe you're going to get 9 days of DXL development, assuming the DOORS engineer knows how to program it. And that will get you some textual analysis, but it'll also give you a burden of ongoing maintenance. And that is also a big issue with DXL developed in-house, is you're going to have to maintain it. So I should be coming up fairly quickly. I've got a minute to go before the questions. So let me answer the question. Can script-based languages actually hack the NLP? Well, let's look at this. Yes, script-based languages, DXL, yes, can do textual analysis without a doubt. But the data structures are severely challenged, and memory leaks and performance, they will be issues. Can it do natural language processing? I'm afraid I don't believe it can. I suppose you probably could shoehorn it in, but you know, it's going to be an absolute nightmare. So the reason is that natural language processing extracts meaning. Meaning is about relationships. And so a relational database or equivalent, I believe, is required to do this effectively. What I'm saying is don't use a hammer on a screw. It's not the tool for the job. This is the tool for the job. Here comes the advert. This is the tool suite that you can get. And this is the tool that will do natural language processing, and it will give you much better, much higher quality requirements in a very short period of time. So, thank you very much for listening. I've hit my time mark, which I'm rather pleased about. It's now questions and answers.
Thank you, Simon. I think that it was a very, very, very interesting speech about this topic. Now it is your turn to come up with your questions. Remember that you are mute, so please write down your questions in the chatting box.
Jose, are you going to talk about the next?
Yeah, absolutely. So in the meantime, while you prepare your questions, let me just remind you our next webinar. It will be held on the 8th and 9th of May. The topic for this next webinar is procuring systems PQS for smart acquisition. PQS is a library we have created for SQA. An interesting feature in the current version of our tool is that now it is feasible, it is possible to create and come up with your own libraries. And we have created a library for procuring and acquisition. This library is including ontology content, is including patterns, is including templates, is including processes, including lessons learned, and a lot of interesting stuff that you can benefit of when during the acquisition processes. So as you can see here in the content of this webinar, everything will be about the competition in fair and transparent manner is the heart of procurement. That is why you probably already have a process in place to ensure the legal aspect of fairness, integrity, and transparency throughout the competition. But what about the two other cornerstones and key guiding principles of economy and effectiveness, and not list of principle of best value for money? This sheet guarantees that the purchasing body is conducting the procurement process with maximum effectiveness in relation to overall budget, and that the principle of best value for money is indisputable and crystal clear from the initiation of procurement project through the requirement definition, strategy selection, and finally bid evaluation and selection. As I said, if you're interested in this topic, please follow our announcements in the website and in the social media, and book your seat for this webinar. Let me check if we have any question. Okay, we have some here. Simon, are you ready?
Yeah, I'm ready.
So the first one is, any other script-based language aside of DXL is well known in the industry?
Well, that's a good question, because back in 1999, when we were doing the requirements counselor, we thought about using Visual Basic for applications, because we wanted it embedded in Word rather than having to work off ASCII text files. And guess what? Because like DXL, VBA is a interpreted language, it was slow, and the functions that we had could only really do sort of basic textual analysis, and we actually gave up on using VBA and went to well, in those days it was called C++. I suppose it's called C# now, and so yes, the other languages that are available, things like Python as well, or JavaScript, those are going to have similar problems, I believe. Some of them have a natural connection with relational databases. They've got functions to allow you to do that. But of course, DOORS can be connected to a relational database, which is exactly how our tools, we have a DOORS plugin, which gives the results of our calculations directly into DOORS. So there is a possibility of getting access to relational databases from other languages, yes. But I think the problem with interpreted languages is garbage collection, which is always going to be a problem, and a compiled language typically is going to be both faster, quicker, and better.
Good, interesting. I have here three pretty much related questions that probably I can sum up into only one. So the first one is, in your opinion, do you think that this memory leakage in DXL regarding the string tables and management will be fixed in the near future? So this is one of the questions, and we have two more mentioning those next generation. So I do believe that these three questions are pretty much alike. Yeah,
totally. So, no, I don't think DOORS old gen is going to get the memory fixed. I don't see it in IBM's best interest to do that. IBM, not surprisingly, is moving their requirements platform to a relational database. Underneath new gen DOORS is the JAS platform, which is running a relational database. So yes, there's going to be better processing, but you're not going to get DXL, as far as I understand. I mean, if somebody from IBM can correct me, you're not going to have DXL in DOORS new gen. You're going to have, I guess you could have some SQL, or they may open up an API to their functionality, in which case you could use something like C#. So there's a possibility of doing it that way. If I remember rightly, though, NextGen uses a standard text editor. I can't remember the name. It's the TK editor, I think. And of course, we already have an interface into the TK editor and DOORS NextGen. So you can be working in DOORS NextGen and still use the reuse tools. You don't have to develop the software. It should be there available already. Okay?
Yep. We have another question. I think that you have already mentioned about this. So the question is, could you access a relational database from DOORS and therefore get over the challenges you have talked about?
Well, you're going to have to do a lot of SQL programming on the database side of things. So yeah, you could do it that way, but you know it's going to cost a lot of money to do that. And you're going to always have the maintenance problem. So yeah, I've never done it. Let me think. You can of course set off commands of a command line. So in theory, yes, you could do it, but I'm guessing it's going to be a relatively slow way of doing it, particularly when there are solutions out there already that provide this functionality.
Very good. Thank you, Simon. There are no other questions. Do you have any other questions? We have a couple of minutes if you have more questions. Well, it seems that there are no more questions.
Okay.
So thank you for your time, and please stay tuned. I'm looking forward to meeting you next, our next webinar. Thank you.
Absolutely. Bye for now.
Bye.
Bye.